Welcome, everybody. I am Roman with HVAC School. Also, this is the VRF Tech Talk podcast takeover. We are here at AHR taking over all the podcast abilities here at the HVAC School booth. I am here with Donald Falese, my partner in VRF Tech Talk podcast. And today we kind of want to talk about what we've seen so far here, all the emerging VRF technologies. I've had the amazing time of going between Gree to Hisense to Daikin to LG. We've been really all over the place to see what this new emerging technology looks like, and we thought we'd just kind of give you a new update of what we've kind of seen. So, what have you seen out there, Donald?
I think probably the coolest thing I've seen so far is in the residential side of the Medea tent or the Medea booth. They have a air handler that's modular.
Okay.
So it's a
multi-piece
air handler that's reminiscent of, say, a split furnace and AC coil, but it's completely DX. So the fan section splits from the DX coil, so you can arrange it how you need to in the attic space, and
it's multi-position.
So it can be left, right, downflow, upflow.
Yeah, no, I'd say one of the other cool things with that is that I was also over at Hisense booth and talking to a good friend of ours, Steve Cook, and one of the coolest products I saw was the one that he has on his house, and it's a single phase VRF system. That's actually has a hot water heater that's connected to it. And so it's actually heat recovery, but the heat recovery is two pipe. And so they're like, well, how does that work? And it's like, okay, well, when it's not actually expelling heat outside into the atmosphere, like in a Florida market where we're predominantly cooling, it takes that heat and it actually transfers it to the water inside. And so it's that residential single phase system of all the monoblocks that we've been talking about. But VRF, like he was like four indoor units connected.
I think that's pretty cool, and it's prevalent at almost all the manufacturers' booths that they have some kind of water to air heat pump for the market that isn't there currently in the VRF sphere.
Yes,
so it's pretty neat to see that that's coming to bridge the gap between the commercial side and the residential side of the VRF market.
Yeah, when you come to HR, you're looking for brand new products. You're looking for cutting edge technology. You're looking for all these giant manufacturers that you wouldn't really like. I even saw TCL, my TV in my living room. They have an entire VRF product line here at AHR, and so there's these brands that you don't think about who are in our market and are starting to make that headway. Such as Hisense. And so, you saw a modular air handler, which is a high demand too, being able to take an air handler apart in pieces and take it up into an attic.
Take it in the attic. That was the main selling point, is like in their display, they show you a guy carrying it up in the attic.
Yeah.
By pieces.
Yes. And it's not like a million screws, right? Yeah. We had the good fortune of actually getting with Medea with the business development side of AHR that we also were a part of as well. And that was one of the things that I saw the video that they sent over to me was that product and alone itself. And it's cool, man. Again, the last AHR I went to was in 2019, and it kind of lit this fire under me that man, there's a ton of stuff we don't know.
This is my first visit to AHR, and I'm just blown away by the sheer amount of things I don't know about here. I'm, commercial VRV through and through, and just blown away at how huge this industry really is.
It's massive, man. It's massive. And, we'd love to sit here on our soapboxes and say, oh, we're only one brand, we're only this, we're only that, you should only do this. But there's so many brands out there now that are doing exactly this in just a different flavor. You think about Mitsubishi, which has their 2-pipe heat recovery. You think about Daikin, which is 3-pipe, and their advantages and disadvantages. And there's everybody who's got a version of one of those, right? You fall into one of those buckets.
Yeah. And another interesting thing I saw at the Cooper Hunter booth is they have a branch controller box that is 2-pipe in, 1-pipe out.
Yes.
So I've never seen anything like that. So we got to ask them, I was like, how does this work? And then they were more salesy in group. So, logically I'm thinking, oh, that's your hot gas and your suction on the inlet side. And it's one out. That makes tons of sense.
Yeah.
Yeah, so it was pretty cool to see something I've never seen in the VRF industry, right? Because I'm very used to 2-pipe, 3-pipe.
Yep.
Here's your branch controller.
Yep.
But seeing a single port branch controller with one outlet, it kind of shocked me a little bit.
You're like, wait a minute, what are we doing here? Like,
Right.
do I have to relearn this all over again?
Well, my question was, where does liquid go? It just goes right to the unit.
We don't need it.
Don't need to. It doesn't have to go to the box.
It's wireless.
Yeah, it's Bluetooth liquid.
And so speaking about wireless, another great thing that I saw at Hisense, not to toot Steve's horn here too much, was that they're brand new. I would say it's probably their, I don't want to say VRF 5, right? I'm butchering it. It's probably, I think it was VRF like S5. He's going to correct me later. But the coolest thing, so you have the front of the service panel, and it's kind of like a weird gray color, but then down at the bottom, maybe about knee level height, there's a square, and that square is where you take your phone and your app and you download it, and you actually just touch the panel.
Yeah.
And it actually pulls in all of your field settings. It pulls in some of your service data. It pulls in your model numbers, your serial numbers, all the things you need to commission it. And then you're able to change the field settings on your phone and then touch it back to the unit, and they get uploaded to the unit. You can put the unit into test mode. You can put the unit into forced on mode. Yeah. I mean, it opens solenoid valves for refrigerant recovery all from your cell phone.
Yeah, that near field communication technology. It's existed in our wallets for a long time with our credit cards that have the chip, right?
Yes.
So why not apply it to something useful for the technician?
Well, and that's the thing. So like, VRF is already and I told this to him, so I'll redo it again, but VRF is already as complicated as it is, and it's scaring a lot of people away from the trades. But you have to look back and think, okay, what is the manufacturer doing or able to do to actually help alleviate that? And I think they've done it, because, again, you don't need to pull out your laptop. You don't need to pull out your service tools. You don't need to hook them all up just to see these tiny little things. You're actually able to go in and just take your cell phone, tap a unit, and get a service manual.
Right.
And he was even saying, this blows my mind, how like light years ahead they are in the industry. Because I think this is going to drive it home for a lot of people to where like other manufacturers, hey, you need to catch up here. Because when we talk about, that technology, he's like, well, when you even do remote troubleshooting with Hisense over the phone, they can connect to your app and you can tag the unit, and they can pull information off of that, then goes to them to see the system. And it blows my mind, just all the little things. And of course their unit wasn't powered, so I couldn't like download the app and actually do it, because I want to see it. But
that's the dream of every technician that's been on the roof waiting for a callback for 3-4 hours, and then
or the issue of finding like that particular flavor. There's one VRV3 service manual out there that no one can find, right? The PTJU. And it's like, well, mate, do you have it?
If you need it, I have it.
We sell information on the down low. But again, to that point, sometimes finding the information, getting the information in technicians' hands is extremely difficult. Yeah. And so they're bridging that gap. But again, like, just thinking ahead and saying, hey, how do we make this easier for people? How do we jump into something like that? So
absolutely.
But yeah, no. So again, Hisense, Medea, and I even saw Gree, and Gree's got some really cool stuff too. You would think about all these like no names, and Gree's been in the business of making like VRF and compressor components for like 30 plus years.
Yeah.
But we kind of step back and we go, what's no name? And it's like, well, no, you just haven't heard of it yet, right? You haven't seen it yet.
You have seen it. You just didn't know you did.
Well, and that's the other thing too. Gree's name is just about on everything. It's just not on the outside, right? It's made by them. It's serviced by them. So it's just really cool stuff, man. I got to say, every time I see the posts from this place or when the expo happens, there's always some kind of like brand new thing that comes to the market. And it's like, wow, that's really cool.
Talk about brand new to the market. And this is taking the commercial to a larger scope, is the emergence of air source heat pump chillers. So right down the booth from here, Medea has a 40-ton module heat pump inverter-driven chiller.
Wow.
Which is insanely cool.
That is cool. That is really cool. It's funny. I also did a video recently with Copeland and their inverter compressor. So they actually have a vapor injection compressor that they just rolled out, and it's like I'm going to misquote it here. It's probably I remember the low end. I think it was like 5 tons to 25 tons. But like you think about limiting technologies, and usually limiting technologies comes into play when we're talking about sizing and capacity. Like there's a reason VRF hasn't overtaken the chiller market, because we don't sell them in 3,000 ton capacities.
Right. It was never the chiller killer. It was just a convenient solution.
It was. And again, it's not going to replace them because of the whole tonnage size. Right. But again, having that ability, and as we start to roll through, the months of this year and get into next year, You're going to find a lot of these manufacturers, especially like Copeland, their partner deal with Daikin to building their rotary swings now. In our market. That's a big move. But to see an actual inverter compressor running off of a drive, which is unusual for us VRF guys, right? Well, where's the inverter board?
Where's the inverter board?
A lot of you applied guys out there have had drives on compressors for a long time with Dan Foss, and you'll find those in those newer Rebel units. But to see that and see the ranges of capacities with that specific compressor, I just want to cut it open, though. That's the problem. Like, I was like, can I cut this open for you guys?
I got to look at the compressor. It's a big boy.
It is a big boy. Yeah, I tried to get the guy to pick it up during the video. He couldn't. I was kidding.
No, they're heavy. But just seeing the inverter technology applied to, the big stuff now, the big chillers.
Yeah.
I mean, LG has something similar at their booth too, and I mean, geez, they brought a full-size chiller. If you haven't seen that,
oh, I know, yeah.
Huge.
When you get these people who are like, "Well, inverters," it's like it's a fad, right? Inverters are going to go away. Like they've been around forever.
We just didn't call it an inverter.
We didn't call it an inverter, and now we're getting to the point where it's either an inverter, which is technically a VFD, and a VFD is an inverter. Like we're just swapping terms around here, but they're not going anywhere. Like they've been here forever. They're getting bigger. They're putting them in more things. We're doing vapor injection now in a lot of different formats and platforms for that low ambient heating capacity. Like you're not going to get away from it. So, now's the time to get into the trade, to start looking at VRF and understanding the basic components on how we took a mini split and just upscaled it. Right. And we added a few extra components. We added a few extra pressure transducers and temperature sensors. Extra piping. We took away some piping on some manufacturers, 2 pipes to 1 pipe.
But I think really the name of the game is efficiency, and inverter technology is going to drive us there. Yeah. No, and I don't disagree with that. And, for all those guys out there who think that they're missing a lot here, like this is a very big event. There's a lot of people here. It's exhausting. Donald was happy to sit here and get off his feet from all the break. And we're only on day one. Yeah.
And so,
through day one.
There's a lot of great stuff here, but all of this stuff's online, right? All of this stuff is outward facing, and HVAC School has been doing a good job on getting that information out there. And we're going to do more stuff about VRF, inverters. A lot of this expo is just meeting people and seeing the technology that's out there. Because again, like you said, and for myself, you can walk the floor 5 to 6 times and still find something new that you've never seen before.
Every corner of this building and the gravity of the size of this building is like nothing I've ever seen, and it's packed wall to wall.
It is. No, and so, for those techs out there who are looking to take it to the next level, who are looking to get that information that's out there, you can go to the big manufacturers' websites, right? You can go and look up videos on YouTube. There's really no excuse not to find something to dive into and start to peel back. I mean, we have our first episode. I don't know if this would consider a second episode.
It's just a teaser.
Is this the teaser? Yeah. Okay. And then, I've got a YouTube channel where I've got a bunch of inverter videos out there, a bunch of VRF videos out there. And again, all that stuff is free. It's just a matter of getting that information to the people who are looking for it, who are hungry for it.
Well, even if you're not looking for it, learn something new every day.
Yeah. Well, and that's the whole thing, right? I'm going to butcher. What does Brian say in his podcast?
You don't know what you don't know.
No, I don't think he says that. Hold on. What's his catchphrase? Something along the lines of like, something that you learn one time or something like that, and then you're going back to learn it again. I'm completely butchering it. I work for the guy, so clearly I don't listen to his podcast.
No, it's just keep an open mind and learn something every day.
Yeah, and again, the big thing here too is when we talk about VRF, we talk about the different brands that are here and all their new technologies. They're going to call it something different, right? And they're going to trademark it. The VRF 3000. Who was it? Hisense was calling it the Extreme, right? Extreme. And so, they're not doing anything we aren't already doing, right? Low ambient heat pump, we achieve that by using vapor injection, right? We're loading the scroll when compression ratio is high. We're taking our liquid from one side of the system. We run it through a subcool valve, right? Where we take a refrigerant flow it the opposite way, turn it into a low pressure saturated state. That saturation then boils off into a vapor. That temperature goes into the liquid the opposite way, and the byproduct is subcooling. We take that vapor, and instead of dumping it into the suction line, we build up the pressure in the line, which then pushes open a check valve on the actual compressor, and you get vapor injection. Where does it load the scrolls up? Well, halfway through the compression process, because again, it's just not there. In low ambience, your suction pressure is 80 PSI, 70 PSI. There's just not enough volume there to actually make it into the compressor to get that that compression ratio that you need. And so vapor injection bridges that gap.
Right.
We short cycle the refrigerant and we put it in a high pressure state, and then we dump it into the actual compressor mid-compression process. And again, you're going to find people who call it all sorts of weird things, and they call it liquid injection. It is not liquid injection. I had it out with the Medea guys the other day because they're scrolls don't like liquid. I don't know how many videos of teardowns I need to make you to tell you that, but scrolls don't like liquid. And so they may call it liquid injection. Those are sales guys who don't know what they're talking about. It's vapor injection, right? These are vapor compressors. And so again, they're going to call it some new technology, and you're going to get super worried because you have to go to a service call for that new technology. But remember, they're doing what everybody else is doing. And now Copeland has something like it too, which is going to go in their DOAS systems. It's going to go into probably captive air systems. I mean,
at the Fulton booth, they have a water heater that has compressors in it that have vapor injection.
Wow.
Water heater.
Wow.
And that was kind of really shocking for me to see. Is you guys make hot water with boilers? What are you doing with compressors?
Well, and so there's that efficiency purpose of it, right? So there's nothing out there that's as efficient as a heat pump. And then when you add vapor injection into a compressor, you're supercharging the compressor at low ambience. So you remember, like, everything is limited by its environment, right?
And imagination.
Well, and imagination too.
We're getting pretty deep into technology, and every step forward is just increasing that efficiency and that ability to make the end user more happy with what they bought.
And you're going to find people out there like Toshiba. I think they came out with like a triple rotary VRF compressor like a year ago, something like that. But it's just one of those things where, like, again, like, rotary technology is not new. It's driving my mini split at home. It's driving my VRF system at home. It's not like a brand new technology. And so when we peel back these layers on these products and their names and their fancy sales, whatever gimmicks of patented technology, right, it's just the same thing. You go back to the basics, right? Focus on the basics and understanding, okay, they're not doing something new. They're not creating something from nothing. They're not dissipating heat in a way that no one's ever done it before. We move heat the same way we've had for forever. It feels like, I'd say 100 years, but refrigeration hasn't been around that long. But and refrigeration does the same thing. We call it a subcooler in VRF. Refrigeration calls it an economizer, right? They've got flash pots, they've got all these other things. I mean, they're universal language across the board. We're doing the same thing.
Right. Just the scale of it just changes.
That's it, right? They're doing hermetic compressors. We're doing, semi-hermetic. We're doing scrolls. We're doing, we got some rotaries. We got some swing compressors. Yes. And so, I had someone ask me today about, like, well, what's the difference between a rotary and a swing? And it's like, well, a rotary, right? We're rotating like that. Swing is a version of the rotary. It's that one solid piece.
The piece that moves, right? So the rotary compressor is on an eccentric shaft, so it spins around like this.
Yep. There's
a fixed piece of that, or there's a not fixed piece of that. So that's
one's on a spring,
right?
Yep.
That's the difference between swing and rotary.
Correct. Yes, and it's not like it's okay. One's better. Well, I guess they say swing is better, right? Because less moving parts,
less leakage too past that vein.
Yes, which is higher efficiency, right? Because you're not losing any refrigerant in the process of compression, which is important. But also, I'd say they're both pretty rugged in technology.
We'll take my bread and butter, the VRV S series.
Yes.
They've been using basically the same compressor for the past 10 years.
Yes. Well, and here's something crazy that blew my mind. I was over at the Copeland booth, and we just finished recording about the Sensi and their new vapor injected inverter compressor, YAW. And I was like, what does YAW stand for? It's like, they're just letters.
Yeah.
I'm like, what? You can't just put acronyms in a name and then not give them like some kind of designation. Like, I need to know. But they had next to that, and I was like, well, let's talk about this. And they're like, well, we don't really, and I'm like, well, no, what is it? And they're like, oh, it's an inverter scroll compressor. I have the suction connection on the top, and they have the discharge section at the very bottom. It's 2 inches from the bottom.
Interesting.
And I was like, what is this? And they're like, oh, well, and I was like, well, this is the suction and this is the discharge, because you can tell the sizes. He's like, well, that's a really good observation. And I'm like, okay, what can you tell me about it? And he's like, that's it. Like, this is suction and that's discharge. And I'm like, well, how do you have a discharge port 2 inches from the bottom and not discharge all your oil out of the compressor? I'm pretty sure they have a copper tube connected down to the actual port that goes through the compressor. Okay. So it's just sitting in the oil, I think.
I wonder if that's does that provide any additional cooling?
I don't know. That's what I was thinking. I was thinking if you're discharging hot gas and then you're going down through the oil sump, basically, because again, it's at the bottom, like it's in the base pan. And I'm like,
Let's go take a look.
I know, it's super cool. And I was like, well, what's the tonnage? And he was like, well, this one is like a 2-ton. And this one is a 5-ton, and they're inverter scrolls. And I saw their inverter board, and it's set up pretty well. They combine the noise filter with the actual capacitors and inverter circuit, so it's all one package. But to that point, it's like, well, this is suction at the very top, and this is Copeland.
Yeah.
And you're like, no, this is wrong. Like, you guys, someone at the factory messed up, and they were like, oh, we put this in the wrong spot. This is suction, and this is actual hot gas discharge. And I was like, man, you guys are like, you're blowing my mind here and doing something we've never seen before.
Yeah.
Or you just thought you would just screw with us and put it in a spot that doesn't make sense.
Yeah, I mean, it's again, technology, right? Somebody did that for a reason.
Yes. No. And again, I love cutting compressors open. Everybody knows that. And so I was like, man, I really love getting my hands on this just to see inside. And I'm like, you guys need to have a cutaway. And they're like, well, next year. And I was like, well, I can't wait till next year.
See me after the show.
Yeah. No. It might go missing. But from that perspective, it goes to show you that you don't know everything, right? I don't know everything. I'll be the first to admit it, right? Brian doesn't know everything, and it's only because he's standing here and I can say that. But it's this thing where you should never stop learning. Don't take things for granted, but also you have to question the status quo, right? You look at something like that, and that doesn't make sense to me because no one's explained it yet, and it is new. And so one of those things is kind of stepping outside your comfort zone. That if you've never seen it before, still just look at it and ask the questions. How are you doing this?
Right? If it piques your interest, then go look for more information.
Yes, chase after it. Don't be afraid of it. And you're gonna screw up, and you're gonna make you're gonna make mistakes. You're gonna have problems, and you're gonna have jobs where you can't solve it. And that doesn't mean that you're not a good technician and that you're not good at your job. It just means that you just haven't found the answer yet. And so don't give up. There's a lot of guys out there where this technology is chewed up to spit them out. And I had a tech the other day who was on a roof for a Daikin system. And he was there for one error code, and it turned into like 4 systems. Yep. And they all went down at like the same time. And he's jumping between units, and he's got no idea what's going on. And they're all different error codes, and they're all different problems, and they're all different failures. And it's just, and I'm like, man, I'm sorry. Like, he's pulling his hair out. Yep. And he finally got to the bottom of it after about a day and a half, 2 days out there. But it's just one of those things where sometimes it chews you up and spits you out. Yeah. And you just have to remember that, like, we've all been there, and it's not fun, and this is not easy.
It goes back to what we talked about a couple weeks ago. Is just take your time.
Yeah, and you're not alone. It's you feel like you're the worst technician in the world, but I can guarantee you there's worse ones out there.
We all feel that way once in a while.
Yeah. Well, then the message here is don't give up. Yeah, don't give up.
Learn from mistakes and move past it.
That's it. And never stop learning, right? Never stop learning. If you have that attitude of, I just don't know it yet, I haven't figured it out yet, and I'm not going to give up, then you will eventually conquer the problem and get to the point where, like, it's no longer a problem, and you're succeeding. And so,
next time it happens, you're one step up already. You're going to solve it faster. You're going to figure it out.
Yes.
You're going to go through that same troubleshooting method that got you to that victory, and you're going to succeed.
Yes. So one of the products that I want to talk to you about, because this is not like something that's saturated in the Florida market by any means, is water-cooled VRF. And so Hisense had a water-cooled VRF system that everything was completely accessible from the front. Nothing was tucked behind anything. The EEV was right up front. And then they had a side panel that came off, and you could see the compressor. You could see the accumulator. You could literally see everything. I mean, what brands have you guys? Because you guys, is it mainly Daikin that you guys sell? Okay.
Strictly Daikin, yeah.
Okay. So with that being said, I mean, how much water cooled do you guys sell in your market?
I'd say it's probably a 35 to 40%.
Okay, that's a lot. Yeah. I mean, I'm not saying there isn't any here. It's just I haven't seen it yet or touched it, but it has its advantages. So when you see VRF installed out in the field, when we talk about water source and stuff like that, is it on a ground loop? Is it?
It really depends on the project. So on some of the newer projects, yes, they'll go on a ground loop just because that source is there. But the majority of the water cooled that we're doing in the field is for retrofit buildings.
Okay.
So the existing water loop is in place. All they need to do is add the condensers to the loop.
Yep. And then the refrigerant lines for the VRF system.
Lines for the system after that, yeah.
Okay. So what's the biggest sales pitch, I would say? I mean, because, we're not sales guys by any means, but sometimes we have to have those conversations with clients. When you go to a chilled water system and you're retrofitting it over to like a water-cooled VRF heat recovery system, it's the heat recovery part that makes it efficient, right? Yeah.
So you also have less power consumption too, right? Okay. So you're going to have no fans to worry about for power consumption. So that goes down. But the other part that is the water-cooled systems are highly modular compared to the air-cooled. So depending on what kind of building you're putting that into. So in a retrofit, that's say it's a mid-rise building, 10-story building, you might be able to split those water closets up to 4 or 5 per floor, rather than piping all the way up to the condensing loop or worrying about running the big bore water pipe down all the way down to the bottom of the building. And it just depends on the project. But I think most of the cost savings is going to come from the energy efficiency of that.
Okay. So let's shift gears from sales and get straight into the nitty gritty. What are the most failures you see associated with water cool?
Lack of maintenance on the water loop.
Okay. And that, so, when we're talking about troubleshooting, and I've seen that many times, my horror story goes back to when I was a field support manager with Daikin, and we had a building that had blew all the soft plugs in like 9 systems. It was like a total of like 1,000 pounds of refrigerant. And everybody wants to blame the manufacturer. And so when I arrived on site to look at the system and evaluate it with the rep, we found that the water loop for that system was 134 degrees.
Yeah, that's pretty toasty.
And so, when we talk about water cooled, 9 times out of 10, it's always about the flow, right? It's either plug strainers or clog strainers on the water loop, or water loop that's outside of the actual like temperature ranges that it's supposed to be. You have to remember that we're trying to exchange heat.
Yeah, the big one that we see is contamination in the loop. So if you got an open source tower and you don't have a secondary heat exchanger, that gook, that nasty stuff that's in your tower is gonna go to the braze plate heat exchanger.
Yes.
Once you clog that up, you're not gonna flow.
No. And is there any cleaning the braze plate heat exchanger? I mean, like backflowing it, or it's tough, huh?
It just depends on how long it goes on. If it starts to develop rust inside of there, you're not cleaning that out.
No, you can't get in there and brush it out. It's not like you just unpack it and unbolt it, right? It's
Toss it, get a new one.
Well, yeah, and so to that point, we showed up on the site, we put service checker on it, and we found the water loop was 134 degrees. And so what does that system actually look like? And that system was in high discharge temperature step down, right? So high discharge temps. Right. Yep. Safety. It was in compressor overamping, overcurrent, right? Step down. It was in all the step downs, but it was still at minimum speed. And the head pressure was 530 psi.
It's trying really hard.
Your suction pressure was 220 psi. And it's sitting there chugging away. And so you think about VRF systems, and they are smart, right? They're smart. And we have safeties where, like, okay, there's a head pressure switch. And if it goes over that or hits that peak limit, it will cut off the system and it turns off. But what happens when your system goes into all these step downs and it still doesn't get better, right? Yeah. It stays in these step downs forever. And so what had happened was the compressors were 234 degrees, right? 240 degrees. And that temperature started migrating down the suction line because there was no flow. It was all hot gas in the system, both on the suction and on the actual discharge side. And so no liquid to be found. And so it migrates down the suction line to the soft plugs, and it blew the soft plugs.
Yeah, absolutely. Right? We've seen it.
Plugs blow at 160 degrees, if you guys don't know, 156 to 163, 64 degrees. And so it doesn't take a ton of heat to blow those soft plugs. And again, you can look at this and say, well, man, the manufacturer was awful and it was a factory defect. They should just put the soft plug somewhere else. No, what happened was that the BMS contractor accidentally left the boiler valve open and overheated the loop. And also the company who had a maintenance guy who'd been working there for 6 months told them to winterize their cooling tower. So there was no water in the cooling tower for it to exchange the heat that was in the loop. And so it was this perfect storm that caused 9 systems to blow their charge in this building that had just been built and commissioned. And so, again, it goes back to the basics. Everybody wants to jump down the throat of the manufacturer for some kind of design issue or software problem. And instead, just look at the science behind it. What are we actually doing in our system? And 9 times out of 10, it's always flow with water cooled.
Check the water. Just like you need air in an air-cooled system, you need water for the water-cooled system.
Well, and commissioning plays a part in that too. Like, what are my lockouts for low temperature? What kind of glycol mixture do I have in the system? Like, there's a lot of field settings that have to be. So let's talk about the one that I hate the most. I'm getting all fired up here. HJ.
Yeah.
Let's talk about that.
Why is it not enabled from the factory to tell us when there's no water flow? Yeah, it makes no sense. For the people that do it day in and day out, it's second nature that you have to enable that. But yes, that can really bite you. You're just sitting there waiting for hours and hours. There's no indication on the thermostats that I'm an alarm.
Yes.
Only place we're seeing that is on the condenser.
Yes.
And you just don't know that it just doesn't have flow.
Yes, and so from the factory, so you guys, we'll catch up to speed really quick. Okay, water-cooled systems, it has a safety device that you're supposed to tie into it called a flow switch. The flow switch tells you if water is flowing through the heat exchanger in the outdoor unit or just in the water loop in general. Make sure there's water flowing before the system turns on, right? Compressors don't start until flow has been achieved and that switch has been closed. A lot of guys out there, they bypass it when they do test operations, stuff like that. And sure, I get it. But the thing I have a problem with, I'm not allowed to say this because I don't work for the manufacturer anymore, is because from the factory, if you have a flow switch problem, it doesn't generate an error code quick enough, right? Unless you change the field settings to tell it to generate the error code quickly. You could have an entire building stuck in restart standby, which happened on a job in Indianapolis. I won't say the name of the customer, where the whole entire building was in restart standby and no one noticed because it was kind of cool outside, or it was in its 50s. And they didn't need any capacity inside, but you go to the actual system and you see it's got an HJ error code, and it's not turning the system off. And they have flow switches where they cut the paddles wrong, and they were on off all day. And the flow was there, but also, it's just one of those things where, these are things that guys aren't looking for.
Right. And then the proper application of the flow device that you're actually using, you mentioned paddle, right? Like what orientation should a paddle be when you're sensing water flow?
Yeah.
Should it be up and down like this? Like, that's one of the common things we see too is, the paddle switch is installed in the wrong orientation.
Yes.
And it will never make.
Well, and you'll find too that there's paddle switches out there that you can actually custom cut down based upon the depth and the dimension of your pipe. And those are okay. 9 times out of 10, if it's not the same guy doing every single one and checking them with a thorough amount of detail or cutting it off a stencil, 9 times out of 10, it usually drags the bottom and doesn't engage.
Yep. You'll be touching the other side of the pipe.
Exactly. And then the alternative is if you cut it too short, thinking, well, I don't want to have that problem, and so let me just cut it too short. And then you'll find that when the flow gets somewhat low, that it also just unchecks and the system turns off. And so flow switches are one of those things where I like to say pressure differential is the way to go.
Yeah, I prefer a differential pressure switch over any of the paddle, or the only other one would be like an ultrasonic sensor, but those are quite spendy. They are.
And that's the other thing too. You get guys out there who are getting projects or getting into water cooled projects for the first time, and then they're not going to go and spend hundreds of dollars on extra accessories. They're going to want either the factory to provide it or the rep to provide it from what they're buying it. But also, maybe those reps don't understand the whole HJ process and all the issues that go along with that. If we talk about flow being the most important thing on a water cooled system, shouldn't we make sure we get it right the first time?
Yeah, you should. You should always have the flow.
I mean, I don't care if you have to do something else. And so,
well, I think the other safety for that is how much does a test port on the water side cost? Not much.
No.
So put a gauge on it.
Yes. Well, and on top of that too, so the way we fixed the hot gas issue to make sure it didn't happen again is we used the DI input contacts on the back of the ITM because DI1, right? That's emergency stop. We use that in combination with an actual temperature sensor, a Dwyer temperature sensor, attached to the actual physical pipe of the inlet of the water on the system to say, hey, if it's above 90 degrees, whatever the limit is for that equipment, cut off and kill all VRV equipment for the building. And guess what? They never blew any more soft plugs. Yeah. And so you got to think about these things of like, okay, is it worth me going the extra mile of spending? Maybe they spent $80 on that temperature sensor that went to a relay, right? And wiring it into the ITM because the ITM was in the same closet as one of the water cooled systems, right? I spent $80 and maybe like $200 for a technician for a couple hours to wire that up, but it saved me 1,000 pounds of refrigerant 6 months into commissioning of the system. I think it's worth it.
Absolutely.
Yeah. And so a lot of these things, guys, when we're thinking about the water flow, you go, well, it's not my job to maintain that. That's the chilled water guys, or that's the building maintenance guys. But you have to remember, like at the end of the day, if your system blows the charge, you're going to be asked a lot of questions as to why the heck that happened and who's going to pay for it. Just think about where the water is and what it's doing. And if you can add a safety device in the circuit and branch it back to an ITM or do something like that, where it's actually going to make sure it kills the equipment in time to save it, just do it.
Then you'll look like the hero.
Well, that's it. And you'll never have issues with it. Right. And so, water cooled is just one of those things where we don't get to play with it enough here in Florida. I know you get to see it a lot, but it does have its little quirks, right? That add up over time to a point where, you start to lose and have issues. So let's talk about the other one that everybody likes to get wrong. And this bothers me because this is installation related. Like most problems, and this is the piping rules that go along with water-cooled systems. You know, we've all seen and argued about the 6.5 foot rule
What is
between
a trap
modules.
and what is not a trap?
Yeah, I can hear Jordan coming somewhere. His ears are standing up.
Somebody said trap.
He's running. I can listen. We can hear him in the background. You know, so when we talk about traps and we talk about doing them correctly, the big thing to remember here is to understand why we do it in the first place. And a lot of this has to do with oil migration when systems are in low load and refrigerants flowing to one module as opposed to the other. And so when we go back to stuff like this, and the reason I have an issue with the manufacturer on this side is because the instructions that are in this giant poster, I mean, it's like 4 foot by 3 foot, that shows you exactly like 17 different scenarios on how to pipe it and what the correct distance is and all the inches. That paper that's folded up into a nice little teeny tiny fit in your hand piece is in the twinning kit box.
Yeah.
And it doesn't even come with the module.
It's in a bad place.
And so, you know, you think about this water-cooled system that loses compressors, and those are built like tanks. Like water-cooled systems, if you're losing compressors, like that thing has been through hell and back. They don't lose compressors easily. But when you think about installing something like that and having the right stuff at hand, you would think that they would put that with the water-cooled module because it's so important, as opposed to putting it in a piece of copper packing. Because if I get a copper kit to pipe systems together,
right, the directions are going in the trash.
The directions are going in the trash. Like I know copper, right? I cut this in, and they fit or they no fit, right? That's the instructions. They don't realize that in that guideline is all the traps up and down. So if you're listening to this and you're installing a water-cooled system and you threw away a box, I would recommend that you go back to the box and you pull out that diagram and hang it on your wall so your wife can yell at you in your office.
Or at least, you know, go back to whoever you bought the equipment from and make sure you get that in the PDF form, because it does have the useful information to keep you successful. Yes.
No, it does. And so these are the little tiny nuggets that we bring to the table because we do it every day. Yeah. And a lot of people don't know that. And so, well, they know that we're super smart. Obviously, we're here, but no.
Smart.
No, but they hear this, right? And they're thinking about, okay, yeah, no, that's right. We do have issues. We do have piping problems. And a lot of this information, unfortunately, isn't all in the right place. It's not easily accessible. It's not easily found. And sometimes it's those little tiny golden nuggets of, hey, if you ever install a twinning kit, I would save that manual because it's super nice to teach your guys the right way and the wrong way to pipe in modules when it comes to water cooled, especially if you're stacking them or putting them side by side. I mean, all that stuff matters.
Right. And it depends on how you're taking the pipe up and out, right? Are you going up to a riser? Are you going up and out and down? Like that is laid out in those guides. And if you don't know, then you didn't know. But the manufacturers, you know, when you have your fourth compressor failure, they're going to ask you why you didn't install it correctly.
Yes. And then so let's talk about this too. Let's talk about serviceability. So when you lose a soft plug on a water cooled system, it is tucked away in the back.
It's hard to get to
from the top. And so when you stack your modules on top of each other, you can't get to it. And so you've got to completely disassemble the unit or pull it completely off the stand. I mean, I get like the refrigerant charge is pulled, but I mean, how much does a water cooled module weigh? 400 pounds, 500 pounds?
600 pounds,
yeah. And so you're not just scooting it out with one technician. It's a whole setup that you got to get out there to pull it out to get to it. So, you know, I'm not saying set up your systems to fail, but you know, serviceability does play a factor in some of these things. And I get you can't avoid it, but you give yourself as much room as you can to make it work.
That's the good thing about the water cooled units is they have a little bit of a more leniency on splitting the condensers if you're working on a twin pair.
Yes. Yeah. And VRF is not maintenance free. And so when you're talking about the maintenance side of things,
that's
right?
A great topic.
Maintenance, it's not maintenance free. Right? Let me segue here. You know, when we talk about how important water is and water cooled systems and flow on systems, you have to remember that the main purpose of all of that and understanding how important it is, then maybe you should be the one that's quoting the maintenance on the water loop. Like if you're servicing the VRV system, just go ahead and own the chilled water loop too. And if they don't want to, that's fine. But again, I would set yourself up for success here and start putting certain safeties in there. Now, there's that mysterious temperature sensors for future expansion that Daikin has on their boards. Believe it or not, if you're pulling service checker data, if you're using the Hero program, if you land temperature sensors, and this is my looking directly at you, when you land temperature sensors, there is a water in and a water out in the actual Daikin VRV water cooled system that will populate in service checker. And people will go, well, does it control error codes? No, it doesn't. Does it turn your system off? No, it doesn't. But again, if I install two temperature sensors, water in and also water out, and I land them actually on the water pipe in and the water pipe out, then when I go to pull my service checker data on a system that might have failed, I can actually see what the water loop temp is, and if I have a differential, right? We're looking for a differential across that coil.
I was going to mention, the differential is going to tell you a whole lot about what's going on in that loop. If you don't have a differential, there's a high chance you don't have flow.
Yes. And so, we think about water source heat pumps. That's basic stuff, right? When you pull out a manual and a water source heat pump, it has that manufacturer recommended 9 to 10 to 11 degree split that it's looking for efficient heat transfer. If you don't have that when the system is operating, maybe it's undercharged, overcharged, not likely. It's a contained system. However, you're more likely to have that sediment that builds up at the bottom of the coaxial cable inside that water source heat pump. VRF is exactly the same. If your water is crap, your heat exchanger gets fouled, and then you lose flow. And the showing of low flow or showing of insufficient flow through a heat exchanger is through high temperature differential. My water coming in is 70 degrees. My water coming out is 120. There's a problem. What does it look like? Maybe the building's on a VFD drive and they were trying to do modular valves with floating on and off. And
my favorite is we maxed out our drives so our pumps could run 100%. Okay, but do you need to supply 30 GPM or 10 GPM?
Yeah, let's talk GPM here, right? And even then, we're getting to the point now where they're trying to undersize pumps by doing modulating valves with water-cooled units.
And it works.
And it does work.
It has to be designed properly.
It has to be designed properly. It has to be set up properly. It has to be commissioned properly. A lot of guys don't know it, but there's a lot of quirks with VRV water cooled that isn't published in the manual and things you have to do to set it up for modulating valves. And so, that stuff's out there, and you can always reach out to me or Donald if you need to on social media, either on Facebook, Instagram, whatever, to just, hey, I got this system. You said something about this on HVAC School. Can you send me that information, right? Well, we will. We've been collecting it for a long time.
Yeah. Feel free.
And so it's one of those things where we want to give it away for free. You just need to hear this now and then ask us for information, and we're going to send it to you. And if you guys haven't checked it out yet, there's also a Facebook page for us VRF addicts called Tech Talk page, VRF Tech Talk.
Tech Talk, yeah.
On Facebook. If you don't answer the questions, we're not letting you in. Just letting you know up front. But it's a group of 4,000 guys now who are all in the trade doing VRF service, who are working out in the field. And it's a place to share information. It's a place that HVAC School Group is.
Yeah, it's the second most tame HVAC group on Facebook.
Yes, second most. Wait, which is the first? That's that. HVAC School. I can say that I work here.
Yeah.
But no, to that point, the purpose of both of those places is to get that information in the right people's hands. And if you're new to service, you're new to getting in the trade, or even new to getting into VRF as a whole, there's a ton of guys out there like myself, like Donald, like Jordan, like Steve, Quentin Butler, Ken Jones, Ryan Finley, all these guys who have been doing this long enough that they want to see people succeed in the trade. There's so much work out there for everybody that holding on to this information, hoarding this information doesn't no one any good. There's too much of it in our market, actually, if you ask me. I mean, I love to see it. And I want to see it here, but I think when it comes to a service side and a serviceability, there's just not enough companies to service all of it.
There's not enough people.
Yes, and so it comes back to understanding what we have here as a whole and wanting to learn about it, wanting to dig deep, wanting to get into it. And so, people are going to say go to the manufacturer classes, and I'm great. It's a great place to start, but there is a lot of advanced stuff that we need to start working through and talking about, and that's what this podcast's for. That's what this team's for. That's what we're trying to do here, not only the HVAC School platform, but also the Tech Talk page. And so if you want to learn it, it's there, right? It's just a matter of finding the right people who can give you that information and actually talk about these complex topics. So, yeah. But water cooled is one of those things where everybody's well, I don't know, maybe not. Yeah, no, I like it. Yeah, we had this problem, we had that problem, and so again, brazing without nitrogen always going to be a problem.
Always a problem.
Yeah. Running it low on charge and not actually calculating your refrigerant line set length or your actual piping diameter, that's a problem. Charge is everything. So if we're talking water cooled out of air cooled, the most important thing, charge and installation, but you got to, that goes hand in hand.
Well, remember, it's always a design system, right? So if we don't know how much piping you have, we don't know how much charge to tell you to put it in.
Yes. Yeah. And again, like I've said before, you can charge it based off service checker. However, the ability to do that and actually have it to where your ambient conditions are perfect, your space temperatures are perfect, your load capacity on the building is perfect is not going to happen.
Right.
That's an impossibility in itself. So you're going to charge it based upon what it sees now.
Yeah.
But what does it see in 2 months?
Later, right.
6 months later, like your demand on the building changes.
I might take some heat for this one, but I believe test mode should be done annually.
Yeah, well, someone's out there like, what? Their head's exploding. So you remember that test mode is designed, and I did a video about this on my channel, my YouTube channel. Test mode is designed to actually run the system, run benchmarks, and set parameters on how the system is supposed to ramp up. It's supposed to ramp down. And so again, anytime you're making changes to refrigerant charge on a VRF system, test operation is key. Test operation is one of those things where, you don't want to just willy-nilly throw it into test operation without looking at anything. But if you understand what it does and when it matters, then once you're doing your preventive maintenance and going through everything with a fine-tooth comb, changing out compressors, I mean, maybe that system has never run test operation with the right charge.
Yeah, and that's horrible for the system, because then it's going to be trying to achieve its best efficiency with, one leg.
Yes. Right? Well, and it's never going to be set up for success. And, you have all these people who say, I hate VRF, and VRF's the worst. Junk. Oh my gosh, it's so junk. And it's just because they've never come across a system that's installed correctly, right? It's not junk. It's not junk technology. It's just they've never seen it witnessed where they actually went through the piping and they measured everything because it matters. They didn't measure the piping diameter because it matters. They didn't build it out in an express report or do the math to find out if it's even the right size with the right charge, to just come back to the full circle of, did I even do the compressor cleanup kit to clean all the contamination out of the 6 compressors that it ate? Right? Because if I go and I fix the charge and I measure the line set and I do all the piping diameter measurements and I go down that route, but it's eaten 6 compressors, but I don't clean up the system, like I'm right back to square one again. And you're going to go, well, Roman, I fixed the charge, but 7 compressors. Here we go. Buckle up. It's going to happen. And so, it sucks. It's difficult. It's expensive, right? Putting filter dryers on VRF is a full day.
It's a hard task.
It is. And if you see what Mitsubishi's selling them for, they're retiring early. No, just kidding.
Played a lot of golf this year.
Yeah, no, it's expensive, but doing the right thing is never cheap most of the times, right? But doing it right the first time is going to save the money in the long run. This is about a return on investment over time. It's about, changing the reputation for VRF equipment in our market and kind of also equipping yourself with the right tools. So this will segue me into my last topic. I'm sorry, we're dragging this on forever, but no, my last topic, I got to see Cool Automation today.
Oh yeah,
and
later tonight.
I was very impressed.
They got a lot of cool stuff.
They do, man. I don't know where they've been hiding all my life, but I'm definitely gonna get hooked up with them now. Cool Automation. Did some videos with them actually today too, so super cool. You talk about a platform that's taking the importance of operational data, taking the importance of temperature sensors and pressure sensors, and putting them all in the right bucket, in the right equations, in the right format to then display that to a building owner, to a technician, to not only help diagnose VRF problems, but also get to the root cause of things, to where, information is everything. Like, we think about Facebook, we think about our phones, we talk on them, and then all of a sudden Amazon wants to sell me something I just talked about. Information is everything, like buying and selling it. So when we talk about that, it applies to VRF in a way where if we're trying to get to the root cause of a problem or an issue, if you're not actually sourcing the data, recording the data, monitoring the data, pulling all those information in and actually looking at it in a nice, structured, easy to see format, you're missing the boat.
Well, I think the key to the Coolmaster product too is putting it at your fingertips, regardless of being on the job site or not.
Yes.
It's in the cloud, right? We all joke about, it's in the cloud, but as a technician,
which cloud is it?
Right? Is it a rain cloud?
Cumulonimbus? What are we talking to your scientists?
But having that information available to you 24 hours a day, no matter where you're at, as long as you have cell service, that keeps you from having to roll a truck to go to the job site every single time there's an issue.
Yeah, or if you even if you have that information and you still roll a truck and you go out there and you pinpoint what the problem is, you can go back and prove that it's been a problem for 6 months since they first started complaining, or since they first started losing compressors. And so, it gets to that point where you're like, aha, here it is. And here's how I prove it, because I already have it.
Yeah. I've successfully implemented it and probably saved another 6 compressors from failure from a very simple issue to find.
Yes.
it just was too large of a system to go through every single unit without having something to look at it, without having to be there.
Yeah, well, let's talk about the busy season, right? So when you're so busy running all those service calls of locking out modules for failed compressors, having something there and having something available to already be tied in and watching it allows you to then just, instead of like rolling that tech from your truck, you can just tie into it and look at it. Now, again, you have to have people to look at it who are trained to look at it. But my thing is, when you talk about VRF as a whole, and you talk about specific brands, they have specific service tools. And those service tools are branded for them, for their equipment, for their stuff. Cool Automation bridges that gap between all manufacturers, which is hard to do.
But it's awesome.
Right? And it's not just that they do VRF, because that's their bread and butter. But they do where they can integrate mini splits, where they can do, all the fancy building management point stuff.
Did you get a look at their new product?
I did.
Yeah.
I did. It's pretty good. It's like, man, where's this been my entire life?
Yeah, it's pretty cool.
And so they're also able to pull in third-party controls. They're able to pull in third-party HVAC systems, right? Like package units and water pumps.
Right.
Oh my gosh, all these things. And so centralizing that information at one point, you don't know what you don't know until you record it and you populate that data in the right spot to then look at it. And they are doing that, right? And they have that. And so I think that, that they are the next step in that inevitable progression as a service technician to have a cool automation tool in your truck, right? Because then you don't need the service checker and the MNet tool and the Dyna Doctor and all the other things. If it's Hisense, you just use your phone. But, for everybody else, you need a laptop and a service tool. And so having something that allows you to tie into a system remotely or even in person and populate that information without being tied to a proprietary tool, I think is the way to go.
Yeah, it's a game changer.
It is. It unlocks a lot of potential and possibilities. And everybody is probably thinking about all the jobs that they could have used something like this on because, again, they didn't want to have to pay for some kind of, third-party product or from the manufacturers, got subscription fees and stuff like that. And I don't even know what the pricing structure is, but I want it. So, I'm excited to talk to them some more about it. So, all right, well, we're coming up here on 51 minutes. We can start to wrap it up. Is there any final thoughts that you want to get out? We've talked about a lot of stuff. So,
no, I think one of the big things I want to share is, this is the first time I came down for the HVAC symposium last week, and then here at to AHR this week. And, it never dawned on me that this would be something that I wanted to do. But now that it's happened, now that I'm here, I'm like, this is something that I think anybody in the industry should do.
Yeah, no, it should be something that you do. I mean, you'll come and you only want to do it once because your feet are going to hurt for like months. But it's one of those things where you come here and you feel like, maybe you work from a mom and pop. Maybe you work for yourself. Maybe you're out there, just grinding away one day at a time, bill to bill, paycheck to paycheck, working for a small company. And you think that, you live in a small industry, right? You're swimming in a small pond. And you come to AHR and you meet all these professionals, you meet all these manufacturers, you meet all these all-stars, especially something like the symposium where it's a bunch of great people who just care about each other.
It's really good.
And you go through all that and you come and you see how big AHR is and how many people actually fly in to do this and see all the equipment. And it really puts you into perspective that like you're a part of this giant brotherhood that is air conditioning, right?
It's a really big community.
A big HVAC, brotherhood to where it's like, okay, maybe I'm not in this small pond like I thought. I'm in this giant pond, and the possibilities are endless, right? It doesn't just stop with you and the company that you work for. It's really whatever you want to make your career in your life and where you want to go. And so
where you go from there.
That's it. Yeah, just don't ever give up and always keep plugging away. So I think that's a perfect spot to leave it. So.
Good deal.
No, thank you for joining me, Donald.
You.
We'll see you on the next one. And this is, we'll say this is a teaser podcast, 53-minute teaser.
There you go.
But I do look forward to making more podcasts with you centered around VRF Tech's, tech talk things about VRF stuff and service ability and all the good things and failure points. So if you're out there and you are curious about this technology and you want to see us make something of a podcast with a specific topic or subject,
shoot us a message.
Shoot us a message. Yeah, shoot us a message, or even go to the channel and join the Facebook group and add your message there. You might find that we've already talked about it.
Yeah.
It just needs to be rehashed. Capillary tubes is always a conversation we're having in the group, and I feel like it comes up like once a week now.
Yeah.
But yeah, so I appreciate it, man. Thank you so much, and I will stop it here.